Welcome back. In this section, we're going to look at some more complicated counting problems. This time, we're going to be using, in addition to the multiplication principle or the principle of inclusion-exclusion, we'll also be using factorials and permutations and combinations. So we might use the multiplication principle because we're doing two tasks, one after another. But maybe the number of ways to do the individual tasks might be a factorial or might be a combination. Or it could be a scenario where there's an either or kind of a moment happening, where either we're doing one task or the other, in which case we're going to use the inclusion exclusion principle. And again, maybe the individual tasks might involve combinations, permutations, factorials, or even the multiplication principle itself. Okay, so let's get going with our very first example. And we are returning to the bakery that we went to back in the multiplication principle section. We first looked at this, the bakery that only has 22 things in it. There are 10 pies, one of each flavor. There's 12 cakes, one of each flavor. And originally it was me and my friend. We were both going in to go buy something. This time I'm the one doing the shopping and I'm going to buy 5 items in total. The question that I have is how many ways are there for me to purchase 5 things if I'm going to select either 2 or 3 items which are pies? So I'm going to start off thinking about the analysis side of this. How am I going to analyze this question and break it down into smaller steps? So first off, I'm looking for the number of ways for me to get 2 or 3 pies. And so right away, I'm remembering my principle of inclusion-exclusion. Just to write it up at the top, remember the principle of inclusion-exclusion said if you wanted to find the number of things in A union B, that would be the number of things in A plus the number of things in B minus the number of things in the overlap, minus the number of things in A intersect B. In the case of this, we're looking for somebody to select either 2 or 3 pies. So either they're going to have 2 pies or they're going to be having 3 pies. They're not going to be able to do both at the same time. So in other words, this is one of those special kind of inclusion exclusions where we don't have any overlap. Remember, we had 2 forms of the inclusion exclusion principle. What if we had an overlap, which was the one where I needed to subtract A intersect B? And then there was the case where A and B, the 2 things I was splitting them into, were disjoint already so that there was no overlap. So that's the idea that I'm going to be using here. If I'm looking for the number of ways to get 2 or 3 pies, then that's just the number of ways to get 2 pies plus the number of ways to get 3 pies. Okay, so that's the first part of my work here. Now I need to think a little bit further because when I'm saying the number of ways to get 2 pies, that's not exactly accurate because I'm not just buying 2 pies. If I'm buying 2 pies and I'm getting 5 things in total, then I'm getting 3 cakes as well as the 2 pies. So really, it's 2 pies and 3 cakes. And when I'm looking for the number of ways to get 3 pies, well, again, if you're getting 3 pies, then that means the other 2 items must be cakes. So now for each of these individual things that I'm counting, the first quantity, number of ways to get 2 pies and 3 cakes, now I'm doing 2 tasks one after another. I'm selecting pies and then I'm selecting cakes. So I need to use the multiplication principle. Same thing for the second one, selecting 3 pies and 2 cakes. There's 2 tasks there. There's selecting pies, and then there's also selecting cakes. Okay, so now let's think about making the selection. For these cakes and pies, I'm just buying them. I'm not then giving them to 5 different people. So there's no particular order that I need to buy these cakes and pies in. In other words, when I buy the pies, I'm not also arranging them. I'm just selecting them. In other words, we're talking about a combination. So let's do it. If I have 10 pies and I want to select 2 of them, there should be 10 C2 ways to do that. And if there's 12 cakes and I'm selecting 3 of them, there should be 12C3 ways to do that. And then for the second quantity, if I'm taking 3 pies from the store, 10C3 ways to do that. And 2 cakes from the store, that's 12C2 ways to do that. And then now I just need to use my calculator to quickly compute, and I find that there's 17,820 ways for me to make my selections. So we begin by breaking things down into either or scenarios. Either or in the sense that there's no overlap, so basically we're just using addition. And then for the individual scenarios, we break them down into tasks. So getting 2 pies was 2 pies and also 3 cakes, so 2 tasks for the multiplication principle. And same thing for 3 pies, that's really 3 pies and 2 cakes. Again, 2 tasks for the multiplication principle. Counting the complement, this is something I briefly mentioned before if you're remembering an earlier example about selecting 2 shoes that don't match. We did this with the multiplication principle, and then I also mentioned that we could have done it a different way by just counting up all the different possible pairs of shoes and then removing the ones that we don't want, the ones that were matching, and we would be left with all the unmatching shoes. That's the idea behind counting the complement. So the idea here is maybe A is not easy to count on its own. The thing that we're actually interested in is really complicated, and maybe a complement is easier to count. So I say, well, I'll count up how many things we have in the universe, how many ways are there to do my activity with no restrictions, and then I count how many ways are there for me to not get the result that I want. And so if I take all of the options minus the ones that I don't want, that should leave me with all the ones that I do want. So that gives us our counting the complement formula, that if we're looking for the number of things inside of A, we could just take the things that are in the universe and remove the ones that we don't want. Remove all the things in A complement. So this formula you will need to know. All right. So we're going to put this into practice with the next example. And again, we're back to the bakery. Before we do this, and before I put the counting the complement into practice, I'm going to just sort of point out why it's useful here. The question is asking us how many ways are there to do our selection of 5 items again if we want to have at least one of the 5 items is a pie. So if I didn't want to think too cleverly, I'd say, well, if I'm looking for the number of ways to get at least 1 pie, then I'm talking about the number of ways to get 1 or 2 or 3 or 4 or 5 pies. And of course, those are all non-overlapping. If you get 1 pie, you're not getting 2. If you had 3 pies, you didn't only have 1 of them. In other words, this is a case of inclusion-exclusion where we don't have to do any subtraction. We can just split it up into a bunch of additions. So the number of ways to get 1 pie plus the number of ways to get 2 pies, all the way up to plus, 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 all the way up to the number of ways to get 5 pies. At this point, if we wanted to do this, we could. It just means that we would have lots of things for us to add up. Because, of course, for each of those, 1 pie, 2 pies, 3 pies, 4 pies, 5 pies, all of those will involve multiplication principle. They'll all involve combinations. That's a lot of stuff to consider. I'm not going to complete this one this way. I'm going to say, actually, there might be an easier way, and that's using the idea of counting the complement. Which is, if we're looking for at least 1 item to be a pie, then we could do that by taking all the possible options and then subtracting the ones that we don't want. So the ones that we want are cases where there's 1 pie, 2 pies, 3 pies, 4 pies, 5 pies. So what we don't want would be the cases where you have 0 pies. And this is going to be a lot faster. Instead of 5 separate things for me to compute, I only have 2 things. I have to find out how many things there are in the universe, and I'd have to find out how many ways there are for me to select 0 pies. And both of those are not too hard to do. Remember, the universe is the number of ways to do our activity with no restriction, and our activity is buying any old 5 items. So the number of ways for me to buy 5 items with no restrictions would be to say, well, you have 10 pies and 12 cakes. You have 22 things in total, and you're going to select 5 of them. So 22C5. That should be the total number of ways for me to buy 5 things from this store. And if I wanted 0 pies, then in other words, I'm only selecting cakes. So my 5 items that I will select will come from the 12 different cakes, or in other words, 12C5. And then I could do the little subtraction and compute and find out that I get 25,542 possible ways for me to do this. Now, one little thing about this is that for our solution that we have, it's pretty compact, at least my counting the complement solution, 22C5 minus 12C5. But if we had actually done it the original way, actually doing all 5 steps, it would look radically different. So if I actually did this as selecting 1 pie or 2 or 3 or 4 or 5, I would have all manner of things for me to compute. From 10C1, 12C4, selecting 1 pie and 4 cakes, 2 pies and 3 cakes, 3 pies and 2 cakes, 4 pies and 1 cake, and then finally just 5 pies. These 2 answers look quite different from each other, and often if you're looking at the answers in the practice questions, the answer will stop there, and it's not always computed out to be a whole number. It's sometimes left in terms of combinations and factorials and permutations. So many students might see one answer and get surprised by the fact that their answer looks quite different, or actually probably the other way around. They might see this answer with counting the complement and they might have tried solving the other way. So don't be surprised or shocked if your answer doesn't always look exactly the same as the one that's in the textbook, in the practice questions. What you should do is actually compute this. So if you did use your calculator and computed what all of this business is up here for my first way of solving it, you'd find it's actually also equal to 25,542. That we've got 2 very different ways of computing exactly the same thing.